everyone. So let's start the session. For those who have joined for the first time, I am Vishakha Pandey. I am PhD third year electrical engineering student from IIT Bombay. I'm working on antennas. So now let's start the session. Today I am a bit under the weather, so I will be sounding a bit low. Sorry for that. Uh, all right, so let's start the session. Okay, so today we will be solving week 3, assignment 3. So the first question is the electric field intensity in polystyrene epsilon r is equals to 2.55.
Madam, screen is not visible.
Oh, I'm sorry about that. Yeah, is it now visible? Visible now?
Yes, ma'am.
Okay. So today we will be solving week 3, assignment 3. The first question is the electric field intensity in polystyrene where epsilon r is equals to 2.55, filling the space between the plates of a parallel plate capacitor is 10 kilovolts per meter. The distance between the plates is 1.55 millimeters. The magnitude of electric field intensity D is uh, okay, so the question here is asking the magnitude of electric field density. Okay, and what is given here is electric field intensity is given. Uh, a capacitor is given, parallel plate capacitor is given, which is filled with polystyrene whose epsilon r is 2.55. Okay, so this is the question which is asked to you. क्वेश्चन बहुत सिंपल सा है, इलेक्ट्रिक फील्ड डेंसिटी पूछा है और इलेक्ट्रिक फील्ड इंटेंसिटी दे रखा है, पैरेलल प्लेट कैपेसिटर बताया है कि पैरेलल प्लेट कैपेसिटर है और उसके बीच में पॉलीस्टीरीन दे रखा है जिसका एप्सिलॉन 2.55 है. कैन एनीवन टेल मी हाउ टू सॉल्व दिस क्वेश्चन? ऑल राइट, इज देयर समवन?
I think,
Epsilon.
hello,
हाँ, go ahead, introduce yourself.
this is Chandni from NSIT, University of Delhi.
Hello,
I
Chandni.
am also a PhD scholar.
Okay.
I think here since we have to calculate electric flux density, am I right? I think we can multiply the permittivity of uh, the polystyrene, which is between the parallel plate capacitor, with the electric field intensity given to us.
Hmm. Yes. Yes. Good, Chandni. Thank you. Yeah. So we will be using this formula. This book is introduction. One second. Let's see the book's name. So the book's name is Introduction to Electromagnetics. David J. Griffith has written this book. It's a really good book, and I would like you to all to refer this book while solving the assignments. One tip to you is that if you will read these books for assignment 3, if you read different parts of this book, you will be the chapter 4 of this book solve many questions from the assignment 3. Okay.
Ma'am, sorry to interrupt you. Can you repeat the name of the book and the author?
Introduction to Electromagnetics. One second. Introduction to Electrodynamics by David J. Griffiths. Okay. Let's let's go back where I was. Yes. Okay. So this is from 4.4 unit, uh, 4.4.1. So here a formula is given which shows us that D for linear dielectric. So the in the question it's given that it's a parallel plate capacitors and it's the yeah, one second. So it's a parallel plate capacitor and one second. So the it has a linear dielectric, so you can use this formula. So the formula says that D is equals to epsilon E, that is epsilon naught epsilon R E. Okay, so yeah, D is given to us, given epsilon is 2.55, so epsilon upon epsilon naught is 2.55, epsilon is 2.55 into epsilon naught. Epsilon naught for a permittivity for free space is 8.85 into 10 to the power minus 12. Electric field is given to us already. So electric field density will be D is equals to epsilon E, that is 2.55 into epsilon naught E. Okay. Okay. So now you will put all the values here and the value for D will be there. So is there any confusion? No? Any doubts you have? You want any, is there if there is any question, then we can discuss or we can go to the next question. Okay, all right, let's go to the next question. So in question 1 the value of P is, yeah, so now you have already found the value of D. Now the value of P is, okay, so the value of P can be written as epsilon naught psi E electric into electric field intensity. Okay, and yeah, that can be epsilon can be written as epsilon naught 1 plus xi e. So to solve this question, okay, yeah, since xi e, since electric susceptibility is not given to us, that is xi is not given to us, there is another formula that we can use. Yes, this we already know the value of D, isn't it? Electric displacement, since we already know the value of D and we already know the value of epsilon naught E, then can we find out the value of P? Yes, we can. It's a simple arithmetics. So here P is equals to polarization, D is equals to epsilon naught E plus P. uh, yeah, so it's simple, you will send P there and this there. You can put all the values, all of the values are given in the question, either in the question or you have already solved here. This will be the value, this will be second. I'm not very used to this pen, sorry. And you have, oh, okay, so then let's go ahead. Question 1, the surface charge density of free charge on the plates is. So surface charge density. So the surface charge density on the plates of capacitor will be electric field intensity equals to surface charge density upon epsilon or epsilon. It comes from Gauss law for a uniformly charged sheet. Alright. So surface charge density will be how much? Epsilon into E. That is equals to the D. That is equals to electric field density. Oh, sorry. So you just have to put the values and you will be able to find out. Sorry. So here surface charge density will be how much? Epsilon E, that is equals to D. We have already found out the value of D, which is equals to 222.675 nanocoulombs per meter square. Okay. Is there any problem? Is there any confusion you have? Or should I go ahead? Yeah. All right. Sorry. Yeah. So question 4 is in question number 1, the surface density of polarization charge is. So now surface density has asked to us surface density of polarization charge is asked to us. Okay, surface density of polarization charge. All right. So, so polarization charge density, that is P. Let's say that rho P is the polarization charge density. So we have already found out the polarization, which is the polarization charge density, which is equals to the polarization charge density P. So sigma P can be written as equal to P, and we have already found out the value of P, that is 137.175. What you can do here is, see, yeah, okay. So here I would suggest you all to go through this chapter 4. You in that, especially the subsection 4.3, 4.3, 4.3 will be very useful to you to solve the questions, okay, for the assignment. Yeah, okay, all right. So charge density will be equal to the polarization, that is, we have already found out the value of polarization, which is equals to 137.175. All right. Do you have any question or should I go ahead? Okay. Now in question number 1, the potential difference between the plates is in volts. Okay. So now the potential difference is asked. Since we have already solved, uh, since we already know the electric field intensity, will we be, how can we solve the, how to solve for potential difference? Can someone tell me how to solve for potential difference?
Ma'am,
Yeah, go ahead.
I'm Gokul from Panimalai Engineering College, Chennai.
Hello, Gokul. Yeah, go ahead.
Ma'am, V is equal to E into D, ma'am.
Yes, very good. Yeah. So the distance between the plates of capacitor here is 1.5 millimeters. So the potential difference between the plates will be V is equals to E into D, and we know the values. We will put it and we will get 15 volts. Okay. Now question number 6. So question number 6 here says consider region 1 Z less than 0 contains a dielectric for which epsilon r is equals to 2.5. Okay, and region 2 Z greater than 0 is characterized by epsilon r is equals to 4. Okay, let E1 is equals to minus 30 AX plus 50 AY plus 70 AZ volts per meter. The D2 is given by. Okay, so this is the question. Yeah. So for this question, something like this is given to us. Region 1 and region 2 is given to us. Okay. Interface between region 1 and region 2 is XY plane, isn't it? Because it has written that for this is Z. Yeah. This is Z less than 0 and this greater than 0. Okay. So region 1 and region 2. Okay. So normal vector to the interface will be Z. Okay. Now it is given in the question that in region 1 epsilon r is epsilon 1 r is equals to 2.5, and for region 2 epsilon r is equals to epsilon 2 r and equal to this given. All right. Now it is also given in the question that electric field in region 1 will be E1. Okay, it is given in the question, this thing. Now let's say that E1, this E1 is, can we break this E1 vector into E1 perpendicular and E1 parallel to the interface? This electric field intensity is for the interface. So with the interface we can write E1 perpendicular 1 and parallel 2. The second component is parallel. Okay. Yeah. Now, since E1 is given to us and it's given that the XY is the interface. Okay. So, E1 perpendicular will be the the one having Z component, isn't it? So, this one. This one. So, this one is 70 Z vector. And E1 parallel will be how much? Minus 30x plus 50y. Okay. Now, let the dielectric displacement vector similarly, like we have decided E1 vector and E2 vector for region 1 and region 2. Similarly, we are defining two vectors for electric displacement vector. Okay, for region 1 and region 2, and we are saying for region 1 it is D1 and for region 2 it is D2. Okay, D1 and D2 can also be decomposed into components parallel and perpendicular to the interface. Okay, like this: D1 perpendicular plus D1 parallel, D2 perpendicular plus D2 parallel. Okay, so tell me, is there any issue till now? Okay, all right, so let's go ahead. Now, the boundary conditions on D perpendicular states that D1 perpendicular minus D2 perpendicular will be equal to sigma f. Okay. Now let's go a book. Okay. So boundary conditions. Okay. So in this boundary condition, there is two boundaries is taken, one above and a second below. So it's written that for it tells us that the discontinuity in the component perpendicular to an interface can be written as this. That is d perpendicular above minus d perpendicular below is equals to sigma f. Okay. Yeah. So here d1 perpendicular minus d2 perpendicular is equals to sigma f. Sigma f is free surface charge density at the interface. Okay. Now here the surface charge density, since it's not given in the question, the surface charge density, free surface charge density is taken as 0. Okay, it's taken as 0 since it is not given in the question, so it is assumed to be 0. Okay, now d1 perpendicular will be equal to d2 perpendicular, isn't it? Now we already know d1 is equals to epsilon 1 e1 perpendicular, epsilon 2 e2 perpendicular. Now we can expand it and we will get something like this: epsilon naught epsilon r e1 perpendicular. We know epsilon r, sorry, we know epsilon naught, we know epsilon r, we know e1 perpendicular. So can we find out the value? Huh? Yeah. So we found out the value, which is equals to 1.547 Z vector nanocoulombs per meter square. Now the second boundary condition for electric field intensity parallel says that E1 parallel will be equal to E2 parallel. Let's go. Okay. Okay. So here E above, E parallel above minus E parallel below is equals to 0. Okay. So we will put that here. This is the boundary condition and we will put it. So we know that E2 parallel is equals to minus 30x plus 50y. No, sorry, this is E1. One second. This is E1. E1 parallel, we know that it's equal to this, and this is equals to E2. This is equals to E2 parallel. Ha. Okay. Now D2 parallel will be equal to, same, put the formula, you know the formula, epsilon 2 E2 parallel, we know E2 parallel, no epsilon naught. We'll put it and we will find out. Now we can write D2, whole D2 will be equal to D2 perpendicular plus D2 parallel, and we will find the value. Right? So do you have any problem here? So do you want me to repeat this again? I can do that as well if you have any issue here. Okay. So first what we did was we defined E1 and E2, E1 perpendicular and the perpendicular component and parallel components for electric field intensity. Then we defined the electric displacement vectors. Then we put all these in the boundary conditions. From there we found the values and then we got the displacement vector. Okay, from the boundary conditions. Now then I will go ahead.
Hello, madam. Madam, the D is electric flux or displacement, madam. The D2 is electric flux only, no?
It's electric displacement vector. It's electric displacement vector.
Okay, madam.
Okay. Here. Okay. Okay. I'm 1 second. All right. So question 6 is done, right? No problem there. Okay. So in question 6, the P2 is given by. Now you already have found the D2. Can you tell me how to find the P2? To find the polarization. It's easy. We have already done that in question number 2.
P,
Yeah.
P
Yes.
which is equal to D minus epsilon D. Question
Yes.
number 2.
Yes. Yes. Can you introduce yourself? What is your name?
I am Arun Raj.
Hello,
Arun
Arun.
Raj.
Yes. Hello, Arun. Yeah. Go ahead.
P which is equal to D minus epsilon D.
Your voice is not very clear to me. Can you repeat?
Uh,
Go
Madam,
ahead.
polarization P which is equal to D minus epsilon DE.
Epsilon D. Uh,
Epsilon D. That formula.
good. So let's go ahead. Yeah. So we have already seen this from the boundary condition, isn't it? It's a D1 perpendicular is equals to D2 perpendicular. That's what it's written here. And then E2 perpendicular will be this. We can find out, we know epsilon 1, we know epsilon 2, we know E1 perpendicular. So E2 perpendicular will be 43.75. Z vector P2 will be D2 minus epsilon E2. So we have already found the D2. We have to subtract the epsilon not E2. Epsilon not E2 vector. So epsilon not E2 vector will be, we know the free space permittivity, we know E2, whole E2, so will be this. Alright, it's just subtraction. D2 we know, epsilon we know, epsilon not we know, E2 vector, whole E2 vector we know. So this will be our answer. Is there any question till here? No? Okay, let's go ahead then. In question number 6, the angle between E1 and the normal to the surface is in degrees. Now can someone tell me how to solve this one? It's angle. It's think about how can we find angle between two vectors. It's that.
AB cos theta.
Yes, yes. Thank you. Who is it?
Arun.
Okay, Arun. Very good. Yeah, so it's AB cos theta. So angle between E1 and normal to the surfaces. Normal normal to the surface was z vector. So E1 dot z, E1 cos theta, we will E1 dot z upon E1 cos theta. Put the value, do the inverse, cos inverse. of this value, and we will find out 39.79. Problem here? Okay, let's go ahead then. Arre, what happened? Sorry. Okay, so question number 9. So question number 9 is conducting spherical cells with radii A is equals to 10 centimeter and B is equals to 30 centimeters are maintained at a potential difference of 100 volts such that V for R is equals to B is equals to 0. Okay, that's V R is equals to A is equals to 100 volts. That is potential difference here. We are talking about the potential difference. If epsilon R is equals to 2.5 in the region, the total charge induced on the shells is given by. Okay. So this question is for two marks. So here two conducting sphericals are given to us. One is of radii 10 and concentric. They are concentric to each other. Okay. One has a radii of 10 centimeter. Another has a radii of 30 centimeters. Okay, and it has a potential difference of 100 volts such that the outer conductor where R is equals to B has a voltage V is equals to 0, and for R is equals to A, voltage V is equals to 100 volts. Now it's written that now this sphere R is equals to 2.5. Now the total charge induced on the shells is given by. Okay, so let's say that on the inner circle there is a positive charge plus q. Okay, and on the outer surface there is a charge of minus q. It's given that the potential here for R is greater than B is equals to 0. Okay, so given there are two conducting cells, equal and opposite charges will be induced, isn't it? So for two conducting cells, if uh, if there is a charge in an inner cell, then the opposite charge will be induced on the outer cell, isn't it? So so let q be the net charge on the inner cell, then the total charge on the outer cell will be minus q, right? Now taking center of the cells as the origin, r equal to 0, and using Gauss law we obtain the electric field at different radii. Sorry. Yeah, sorry, I have viral. Sorry for that. So using Gauss law, we obtain the electric field at different radii. So for R less than A, that is for the for this reason, for the inside of this the inner shell, the electric field intensity will be how much? Can someone tell me? For the for this reason, for R less than A, how much will be the electric field intensity?
Madam, it will be 0.
Yes, good, good. Who is this?
Madam, this is Dr. Swapnil Laudkar from Pune.
Okay, sir. Okay, doctor, sir. Good. What can I say? Yeah. I'm a bit surprised that even. So, are you a PhD? Have you done a? Do you have a doctorate?
Yes, ma'am. I'm actually a faculty.
Okay, okay. You don't need to call me ma'am. I don't have a PhD degree yet. I'm doing my
But
PhD
it's okay,
studies.
ma'am. I feel those who are clearing out the doubts are.
All right. Good. Very good. So let's go ahead. Yeah. So for the inner region, electric field will be equal to 0. For A is equals for R in between A to B, it will be Q upon 4 pi epsilon naught R square vector of R. Vector of R upon R square. And then again it will be 0 for R greater than B. For for R greater than B, it will be again 0. The electric field intensity. So basically the electric field intensity will be from here, from inner cell to the outer cell. That's it. Yeah, the arrows I have already made. This. Yeah, let's go and see the electrostatic potential. Okay. For V, for potential V for R equal to B will be equal to E dot dl from infinity to B minus of E dot dl from infinity to B, which will be equal to 0. Why? It's given in the question. It's equal to 0. And also at the electric field intensity is equals to 0. So it's 0. Alright. Now the potential at R equals to A will be equal to from infinity to A E dot dr. Now we will break this integral into infinity to B and then B to A. So from infinity to B it's a 0 and from B to A it's this. Now we will solve it. B is equals B for R is equals to A Q upon 4 pi epsilon 1 upon A minus 1 upon B. Someone, no voice. Am I not audible to you? Hello?
Hello, madam. You're audible.
Okay, so someone is saying no voice. Arun, can you please check your audio device? I guess your speaker might have some problem. Okay, let's go ahead. Where was I? Yeah, so all the values are given. V is given in the question, that is 100 volts. A is given, B is given, E is given is equals to epsilon naught into epsilon R, that is 2.5 epsilon naught. So 1 upon 4 pi epsilon naught into 1 upon epsilon R, Q upon Q into 1 by A minus 1 by B. All the values are given here instead of Q. So we will put all the values, transfer it to this side, and we will find out the value of Q, which will be equals to 4.167 nanocoulombs. So the induced charge on the shells will be plus minus 4.167 nanocoulombs. That is, inner circle will have plus, outer circle will have minus, or it depends on how you take it. It depends on how you take the signs. The opposite sign on the other shell. Okay. So the induced charge on the cell will be plus minus 4.167 nanocoulombs. Is there any problem you have? Any doubt you have till now? No? Okay. Okay. So question number 10. In question 9, the value of capacitance is given by. Okay. So now it's a two spherical cells. Okay. So there will be a value of capacity. There will be a capacitance, isn't it? So can someone tell me what will be the how to solve for the value of capacitance?
Ma'am,
Go ahead.
Ma'am, C is equal to 4 pi epsilon divided by 1 by A minus 1 by B.
Why are you doing that much? You have already all the way, see from question 10, so it's a common question,
C which is
question
equal to
bank.
QA.
Who is speaking?
Arun madam. C
Yes,
which is equal to Q by V. Already
yes,
voltage is there, no?
yes, yeah. So
Charge also we find out. Q also is there.
yeah, exactly. Good, Arun. So the charge we have already found from here, and potential difference is already given to us, isn't it? So we will just put the values. C is equals to Q by V. We will put the values and we will find out the capacitance C. Okay. Yeah. So this will be the value. All right. So that's it for today. Total 10 questions we have done for today. So is there any problem you have? Yeah. So is there any problem you have till now for this assignment? Okay. Cool. All the best for your assignment, and do download this book. This book is really good to solve the questions, and for reading as well, and it will clear your concepts. And all the best, and bye bye. I will be putting this video. I am recording it. I will be putting it on YouTube, so you can NPTEL team will be sharing the link with you. Okay, you can take a look there. Okay, chalo, bye. All the best.